Too many world problems. Earth will glow orange in 2023. Spread the word. What do you think I've been doing? Besides spreading the word, something to that effect, anyways. I thought we could get on here. I got some thoughts. Some thoughts that are keeping me up, so to speak. Not about what you think, probably, but still interesting. Gravity, dark matter, dark energy, the expansion of the universe. Got some ideas that have been bouncing around for quite a while in that regard. And perhaps talking about with you will help sort them out. You know, the thing people don't realize, and I was just watching this thing about Albert Einstein, is a lot of these people, while they may also been good at math and did math to back things up, a lot of these people just thought about this stuff and then applied math to those thoughts, right? Ultimately, a lot of this stuff is philosophy that with the right understanding, anybody can do. Aliens won't allow nukes. I don't buy that for a second. But so, anyways, so Albert Einstein, he did something that Elon Musk actually does. I'm sure Elon got it from Einstein, is you break an issue down to the very bottom principle, the first principle about it. And that's going to help you figure out, you take something complex and you make it simple. And that's going to help you figure it out. And so, I think we got a lot wrong in physics, in astrophysics, especially in relativity, in terms of the way we think about space-time. And that's to say that in a lot of ways, Einstein got it wrong. But in a lot of ways, he got it right, too. But so, the theory of special relativity essentially states that space-time, well, first of all, it states that space and time are the same thing. Okay, so you wrap your head around that. It also states that gravity is indistinguishable from acceleration, meaning that space is curved when in a gravity well, and your experience of gravity is accelerating through that curvature of space-time, basically, right? That's what Einstein's theory states. Now, separately from that, thanks to the work of Hubble, which Edwin Hubble was a really odd dude, by the way. I think he was from Missouri and he spoke with a British accent because he wanted to be special, and he wore knickers that weren't in style except for the golf course and all kinds of fun stuff. But what he figured out, what he thought he figured out, and now everybody believes, is that the universe is speeding away from us. Essentially, what's accepted in mainstream cosmology is that our local group of galaxies are gravitationally bound to us, and they're not flying away. But everything outside of our local group, every other galaxy, is flying away because the empty space in between is expanding. And so, things further away are accelerating away from us quicker than things closer. It's a proportional relationship, a one-to-one relationship of distance and acceleration. Now, I think that is wrong, depending on how you look at it. Let me ask you this question as kind of a thought experiment. All right? So, put yourself in empty space. Okay? Now, pick a point away from you, relative to you. Say it's however many miles away. Now, take a solar system. And solar systems move. Now, have that solar system move through that point, okay, that you're observing. So you're observing it at, let's keep it simple. Say it's a mile away. Obviously, that's not going to work, but a light year away. Let's go with that. It's a light year away from you. You're observing this empty point. Now, a solar system moves through that, in between you and that. So right in the center of the star, passes through that point, okay? Now, according to relativity, that point that was a light year away from you now is further than a light year away from you without you moving at all, because the space between you and there curved. Now, let me ask you this. This is the question I want you to ask yourself. as that solar system continues to move, does that point in space stay as far away from you as the solar system made it? Does that curvature remain in the wake? Or does it immediately spring back to flat? Answer that question. The best physicists in the world probably couldn't answer it with any certainty. It's because it's not an experiment we've done, and it would be very hard to do. You guys are talking about Trump and welders in the comments, and I'm talking about this. but think about that question. And think about what the answer would mean for the greater questions in physics, right? Does gravity leave a wake? Does it leave a trench, so to speak, in space-time behind a solar system, behind a galaxy? And everything's moving all the time, quite fast. You know, our galaxy is moving, our planet is moving, our star is moving around the galaxy, right? At all times. Which means that in addition to its mass warping space-time, its speed is also warping space-time. So the rate of time passage here on Earth is different than if you went outside the galaxy stationary relative to us. It's different. It's slower, I believe. Yeah, it's the faster you move, the slower time is. And the slower you move, the slower time is. Right? Because space and time are the same thing. They're distorted. And mass and acceleration are the same thing. So E equals mc squared. What does that mean? Energy equals mass times c, the speed of light, squared. Right? Which, if you apply that to be true, you find that that space distortion and the time distortion are resultant of that same thing, because those are the same thing at that level. But here's my thing. So with the expanding universe, imagine you're looking out from Earth, ourselves in a gravity well, inside of a gravity well, inside of a gravity well. So the Earth's gravity well, the solar system's gravity well, which is mostly the sun's gravity well, the galaxy's gravity well, right? So a ditch inside of a ditch inside of a ditch, right? Now imagine light coming from outside of there, from another galaxy. That light is falling into our gravity wells. And especially if, as mass moves through the universe, it's leaving a wake, it's leaving those empty wells behind in some way, shape, or form. I'm not sure exactly what that would look like, but that would mean the light from a far-off galaxy that seemingly is it's redshifted, which they think means it's moving farther away. It doesn't necessarily mean that, is my thought. But so the light is having to not to go straight across, like apparently straight across, because you don't really see that the space is curved. It just looks like, like it does, like flat to us. But so that light from a faraway galaxy is dipping into every gravity well along the way, right? And could perhaps that and the impact of the shift in relative time movement in those gravity wells is causing that redshift at that proportional distance, meaning that the universe isn't flying itself apart. It isn't accelerating apart necessarily. What it could mean is that new space is being created in the slope, so to speak, of these gravity wells. Like, think it's stretching, it's like, ooh, this exercise band. I'll set you up. You're on the charger. That's mine not. Okay, so if this is space-time, right? When I do this, is the rubber expanding? Right? Is it expanding? It's getting more surface area, but the amount of material is the same, even though it takes up more area, right? I think it's probably more like that than this thing growing You know what I mean? It's more like a stretch. Now, the other question is, like when I talk about those wakes in space-time, are those, if they are staying there, that's one thing. But now, if those bounce back after the mass moves along, where is that energy coming from? What is the bounce back of space-time? What is that mechanism? Right? We understand that the mass causes the hole, the stretch out, so to speak, in this fabric of space-time. But what mechanism is causing it to bounce back, if it does? I don't think it is, fully at least. And so I think about dark matter. Dark matter is almost certainly not what they think it is. Like, they're getting closer. They're talking about modified Newtonian dynamics and modified understandings of gravity. What do you think about quantum entanglement? We might get to that. That might be connected to this. We might talk about that. We're in a little bit earlier in Einstein's career at this point. But so, if space-time doesn't bounce back fully, what if perhaps all this dark matter we think we perceive is just the impact of those ripples in space-time, those divots, so to speak, that are left, those wakes? Now think about it like this. So the reason we think there's dark matter is that the outside of galaxies are spinning too fast. And the fact is they should have strewn themselves apart by how fast they're spinning, if not held by more gravity than what we can see, a lot more, like 90% more or something like that, you know? And so here I am thinking, well, and I have to check the math on this. I had this thought earlier. I haven't checked the data we have on it, but theoretically, there's more mass in the outer part of a galaxy than a center overall. Like, obviously, the supermassive black hole, or whatever it is, I think there's more to that story than we know. But the supermassive black hole in the center of most galaxies, obviously, is huge, right? Huge. A huge amount of mass. But is all of the mass of the whole rest of the galaxy more than that? Probably. I'd have to check that. And probably different between different galaxies. But if those are spinning around, making these divots time and time again, could the impact of everywhere that the solar systems are not at the moment, but yet it's still gravitationally messed up, so to speak, distorted, could that account for the extra gravity we observe, for the dark matter we observe? It could literally just be damage to space-time, so to speak, right? I think that could very well explain dark matter, and I've never heard anyone propose that theory or shoot it down, right? I really think that's very possible for dark matter, something along those lines, where it's about those ripples in the fabric that don't get resolved. At least maybe they don't get resolved immediately. Maybe that takes some amount of time for space to bounce back. But we don't have any evidence, to my knowledge, that it would bounce back, right? But so, that's dark matter, potentially, explained by this aspect of gravity I'm proposing. And dark energy as well. Which dark energy is the driving force of the expansion of the universe that they think they observe, the redshift that we observe. And if that dark energy is just light dipping in and out of these gravity wells, or the ruts behind them over distances, then that explains that too. And I think that's pretty revolutionary. Quantum entanglement. You're asking about that in the chat. I have theories. And first, I don't think the science is conclusive. I think that there's a big debate about the double slit experiment being, is it actually a conscious observer or a measurement device interacting with it? And from everything I've heard, and it is kind of strangely not at the top of the articles, you know, but like, apparently it's more about the measurement device than consciousness necessarily, right? But now that doesn't fully explain it. What I think is that so first of all, the reason quantum entanglement freaks people out is because it's instantaneous communication, basically. And it's not as useful as you might think. So if we took two particles, two photons, and entangled them, which is pretty easy to do, and then took one, put it on a spaceship, sent it a light year away, and then measure the spin of the one we still have, we'll then know the spin of that other one, which we didn't know when it left, instantly. And by measuring ours, we are creating that one having that spin, as opposed to a superposition of both spins, right? Whereas if you didn't measure ours and measured that one would be the one that determined what ours was, and it could go either way based on the waveform, the probability. So it's not as useful as you think right away, but also it seems to me that distance, and we talked about how distance and time and all that are the same thing. I like to call it often not real or an illusion, but that's not exactly right. It's more that it's not all there is. It's not all there is. It's not all that is real. There are other real things that are not as apparent to us in our current perception that are just as real and have impacts on the way everything works, right? Certainly space-time is not all there is, even what we observe. But so distance only exists within space-time. But the thing that gives us matter and energy exists also too outside of space-time. It exists also too in a state of superposition with everything else. Everything in the universe is still in that infinitely dense single point of the singularity, but also space-time in between now from where we're at. But at a level enough to matter, is that double entendre? But it's still connected, making things like entanglement simple, because there is no distance or time between them in reality, at a level that those things also exist. That makes sense? One thing I'll add to that question is understanding of where mass comes from. So matter and energy and mass are not the same thing. They're not the same thing. Matter and energy can have mass, but they're not the same. Does that make sense? Mass can be thought of as a drag effect on the Higgs field, which can be thought of as one of many ethers that are everywhere, just like space-time. So if space-time is one ether, which people get mad at me for using that word, but it's exactly the right word. If space-time is one ether, the Higgs field, the thing that gives everything mass, is another ether. And moving through that, which matter and energy are equally moving through the Higgs field as they are through the space-time ether. Which, if you don't like the word ether, you can use the word scalar field. But I think that is also correct. Ether makes more sense to more people, and it's a better word for it. But a scalar field, if you want to look that up. But so matter and energy and you and me are moving through multiple ethers, one of which being what we think of as space-time, one of which being the Higgs field. And I think that there are a few more that also will account. All the ethers together account for everything. Okay, the interaction of these different overlapping, superpositioned ethers. These scalar fields. This is quantum field theory, partially. But so matter and energy, I believe, is akin to yet another ether, so to speak. That its properties in relation to these other ones lead to it being kind of bundled up momentarily, so to speak, twisted up into matter and energy. It's these overlapping ethers that lead to everything else, is my understanding of things. And those, like I said, space-time is just one of those. And they don't exist in our space-time. Space-time is just one of those that we have. Now, can one of these fields create one of the other ones? Or it's like interaction with one of these other fields create ones? Absolutely possible. I don't know the answer to that. It's also possible that all of them create each other. But so, thinking of how you perceive space-time, if you can just add to that there is more than just that, you'll be somewhere.